Hi there, my name is Andony Melathopoulos. I'm an assistant professor in the Department of Horticulture at Oregon State University and Oregon's Pollinator Health Extension Specialist, and I'm so pleased to be presenting on the work of the Oregon Bee Atlas, which is a volunteer-led initiative to inventory the state's native bee fauna. My co-authors include the various staff members of the Atlas situated across 3 different departments at Oregon State University, and all of us serve a large group of dedicated volunteer master melatologists who direct our activities and are the key authors of the work I'm about to describe. And I'm going to be describing it alongside the Oregon Bee Atlas's taxonomist, Lincoln Best, who will be joining me halfway through the presentation. Recently on OSU's weekly podcast Pollination, we hosted Dr. John Asher, who laid the present challenge for native bee survey succinctly. Namely, there's no way of talking about bees in the generic, and that the key obstacle today lies in the very basic work of inventorying bees and understanding their relationship to habitats. As he says here, if we want to understand what's happening with bees, we have to be a lot more specific. We need basic maps of where species live in relationship to habitats and ecoregions. Without this basic work being completed, we threaten to have a survey for generic and common bees which glosses over the rich diversity of bees that we have in the United States. The extent of this problem is illustrated in this wonderful map of substantive native bee surveys conducted in the U.S. spanning back to the 19th century. The authors of this great paper set the criteria for substantive as studies that detected at least 100 species of bees. Now, 2 things should pop out in this map. The first is that large parts of the U.S. have never been concertedly surveyed. Second, when you look at the intensity of the dot color, which depicts the number of species which were detected, much of the bee biodiversity is in the West. And one might expect high diversity in the undersampled area bounded by the border of Oregon, Idaho, and Nevada. Clearly, more survey is necessary in this area, but how best to proceed? Now, one approach to this problem could be a program that pays a series of technicians across the U.S. who would use a standard and repeated protocol, an idea sketched out in this excellent thought piece in Conservation Biology in 2012 during the heady days of the first term of the Obama presidency. As the study shows, for a mere $2.8 million, we would have the capacity to detect a 2% decline in bee communities across the U.S. When we look for direction for what to do here in Oregon, we looked rather to a local example, specifically the Oregon Flora project, which was initiated back in 1994 and has managed to operate independently of the university from a combination of grants, but largely by private donations. The sensibility of this approach is captured in this quote, which starts the first volume of the Flora. Specifically, Lewis and Clark were instructed by Thomas Jefferson to go out and identify everything, but by the time the Flora started, 200 years later, there hadn't been an inventory yet. And they say, instead of a huge agency that could have put a few $1 million into a Flora project, but hasn't and won't, it's heartening to see that many dedicated people will get the job done. This is what we had in the back of our mind when we initiated the Oregon Bee Atlas back in 2018. Now, we were conscious that there were many biodiversity surveys that have relied on volunteers, and some excellent examples in today's program, but many programs that have gotten off the ground frequently succumb to certain pitfalls that we were conscious of when setting up the Atlas. The first pitfall is that volunteer capacities are frequently underestimated, resulting in relatively low investment in volunteer training and their narrow focus on some very basic tasks, such as surveying for bees in something like this local park. These projects frequently stall under the weight of thousands of new records of low scientific importance that have been poorly prepared and with location information that either has not been properly databased or is riddled with errors. This results in a bottleneck where taxonomic experts get overwhelmed and their productivity increasingly diminishes. This taxonomic bottleneck, in turn, has a corrosive effect on volunteers. If volunteers are lucky, years will pass before they get information back on their discoveries. More often than not, their discoveries disappear down a black hole, either because the material never gets determined, or if it does, it's whisked away into a scientific publication with no thread really connecting it back to their effort. Volunteers get discouraged and they fall away. To get around these challenges, we decided to emphasize investment in developing our volunteers. After all, in the Extension Service, this is our bread and butter. This is what we do very well. And we had a sense that this investment would pay off because surveys performed by our team evaluator, Heather Fisher with the OSU STEM Research Center, showed that fully 43% of volunteers had very high ambitions for exploration and discovery. The sentiment is captured by the unofficial motto of the Atlas, to boldly find the bees that no Oregonian has seen before. We also knew there was a large number of dedicated and well-educated volunteers who are willing to put in the time to do a lot more than what most projects expect of volunteers. A great example of this could be seen in the collection submitted 2 winters ago by Master Melatologist Ellen Waterous, who is a retired professional with no previous experience in entomology. Not only are her specimens prepared to museum quality, but she took the time to work through 24 monographs on the family Adrena and successfully identified most of these bees to the subgenus level. For these feats and many others, the year before, she was awarded our annual Determinator Award. Successes like Ellen's are the product of intensive investment in volunteer education through a multi-year program in the Extension Service called the Master Melatologist Program, which is overseen by Jen Holt and Sarah Kincaid. Now, all participants are required to complete a self-paced 6-module online training covering topics such as bee biology, database management, survey techniques, and specimen preparation. The training focuses on practical technique development and includes interactive activities such as the pinning assignment shown here, where the instructor can grade the participants' work using uploaded photographs of the volunteers' growing collection. Key to this training is making sure students understand how to capture records. Core to the Atlas's philosophy is that any workflow should not encumber a volunteer in paperwork, but rather should facilitate their own discovery of the state's native bee fauna in a manner that can also lead to highly accurate records. Here you can see volunteers Martha Richard and Pam Arian combing through a patch of vetch in the Mid-Columbia region. How we accomplish both not encumbering and accurate records is that as they go through this patch and they catch their first bee, they record the plant using iNaturalist and then pool all the bees in a single killing jar off that patch of plants, and then associate the bees in the jar with a unique sample ID generated for the day. Plant and location data is, as I mentioned, captured in iNaturalist. We then extract those records and reformat them using a Python script and reassemble them in an online database with a line for each specimen, where volunteers will then go through, verify the information. We then pull those records to generate location labels that we mail out to each volunteer twice per month. Not only is this exceedingly efficient and error-free, and also gets around one of the volunteers' biggest anxieties, how do I make the labels, but it is resulting in one of the largest databases on bee plant host records. Moreover, we offer resources to the volunteers to help guide their journeys. So, for example, and Lincoln's going to talk about this in a minute, we have priority plant genera that we expect to find high-quality bee records on. And we then go forward and secure collection permits in state and federal areas where these plants occur. And all this information is accessible to the volunteers through a password-protected portal that also contains all their data as well as their grading sheets. It's kind of like their console, their kind of the bridge of their Starship Bee Enterprise. Here, for example, is output that can be found in the portal that provides the volunteers feedback on the bees they've collected. And Lincoln's going to talk a little bit about this. We grade their collections, we get them feedback in that sense. But within 12 months of the bees being submitted, we are Our goal is to get them back at least generic level identifications and a kind of page like this where they can really review their records and sort of plan where they're going to go next and what they want to, where they might want to survey next. We supplement our online training with in-person training where instructors demonstrate survey techniques and how to use genus and species level keys. This includes our 5-day native bee identification course that we were kind of hoping to offer again in August 2021, but we definitely will be offering in 2022. Combined, this has resulted in volunteers who are motivated, knowledgeable, and starting to make remarkable contributions to our knowledge of the bees of Oregon. Moreover, as you can see from this graph, the number of specimens per volunteer, which is a graph of the number of specimens per volunteer, more volunteers submitted collections in 2019, and many expanded the number of bees they caught in the previous year. And you're going to see, Link is going to show you some data on how they did in 2020. But if you recall, volume of specimens can be a double-edged sword that can overwhelm taxonomic capacity, which in our case is OSU's native bee taxonomist, Lincoln Best.
Well, thanks for that wonderful introduction, Andony, and the theme music. Hi, folks. I'm Lincoln Best, taxonomist for the Oregon Bee Atlas and in-house taxonomic impediment. Thanks, Andony, for introducing the Oregon Bee Atlas framework, its educational programming and processes. I'll take a few minutes here to discuss our research objectives broadly and our membership's amazing outcomes so far. The research objectives can be broken down into 3 parts. The first of which is we have an initiative to inventory the bee species of Oregon. We suspect there's maybe 700 or 800 species, and we're accomplishing this using our citizen scientists, of course, and they are sweep netting bees from documented floral hosts using iNaturalist. And this has been quite productive. Secondly, we're initiating statewide monitoring using trapping and again sweep netting, and this is to assess community composition and relative abundance with the hopes that we can detect change over time, which is not easy. And we're doing this now in partnership with Olivia, in collaboration with the BLM in the Cascade-Siskiyou National Monument, adjacent conservation properties held by the Selberg Institute, and through our ARF grant, we've had vein trapping in the Willamette Valley, on the coast, on the eastern slope of the Cascades, in the Upper Columbia, and in the Rogue River Valley. And then finally, I just called this Focus. And essentially, this would represent specialized investigations for species at risk, examining taxonomic and systematic questions, looking at phenology, natural history, and other more specific questions. So far, our membership has collected more than 10,000 samples using sweep nets. This map represents the spatial data for that, and it's taken straight from our iNaturalist group. So these 10,000 plus samples represent on average 7 specimens each, and these are collected from a well-documented floral host. The most prolific surveyors have collected more than 1,000 samples over 3 field seasons, and some of them have taken samples from more than 150 plant species, and a few individuals more than 250 flowering plant species. And of course, in total, those 10,000 samples have been collected from more than 1,100 flowering plant species. That's a lot. This is our general plant hit list that we provide with the membership. It lists 20 groups or genera of plants which host an abundance of bees. They host great visitor richness, and they're also fairly easy to find and identify. And so this gives both of our novice bee hunters and our expert bee hunters some really great options of plants to focus on. Of the more than 1,100 species of flowering plants which have been sampled, there's here we have just the top Asteraceae, and so there's 215 species of Asteraceae which have been sampled, and of course rabbit brush has been sampled more than 250 times, representing now more than 3,000 specimens collected from rabbit brush all over the state. And in this way, the hit list informs our participants, and it enables around 1/3 of the total specimens to be collected from these high-value targets. You know, we're exceptionally fortunate to work in parallel with a well-established Flora, the Oregon Flora. The Flora informs my work immensely, and I'm able to communicate this information to our membership. we're generating tens of thousands of records of bee species plant community preference, but also inversely plant species bee community visitation. And this is for more than 1,100 species. And there's lots of fascinating findings coming out of all this work. One I'd like to highlight is Hoplitus and Marginata. This is a new state record, and it's a very rare species previously only known from Northern California. It appears to be a sedum or a stonecrop specialist, only visiting its particular preferred sedums. And volunteers documented the species and the host plant association from the Siskiyou Mountains to the foot of Mount Jefferson. And credit goes to Joe Engler, the Grants Pass Atlas team, and Brianna Lind, and myself for finding all of their little alpine garden nooks. And also, not only are we finding new state records for species, but also finding many species which haven't been documented in the state in many decades, or sometimes in the country in decades. So Atoposmia oregona is a very rare penstemon specialist, originally collected by Scullin among the lava fields of Mackenzie Pass. This rare bee is only known from a few specimens and has not been documented for more than 60 years in Oregon. In 2018, Ellen Watrous rediscovered this original population on Penstemon davidsoni, and now we know that it can be found more reliably. Talking about tens of thousands of specimens every annual cycle it's a lot, but our membership is excited about taxonomy, and their skills are advancing really, really quickly. We're in the around the 3.5 cycle mark of the program, and in the second year of the program, participants attempted more than 15,000 identifications for more than 190 species and 45 genera, and some individuals identified all of their bees to species and or genera. But still, tens of thousands of specimens every year is a lot, and so how do we handle it? These motivated volunteers, like Brianna Lind, have a desire to work on specific groups. And so in the case of Melasodes, we were able to drop off our Melasodes at Brianna's house. There was around 1,500 to 2,000 specimens. And they worked on those for a few months over the summer last year, and then turned them back in, and I assessed the work, and it was very high quality. They had developed their own barcode reference material, and so we're able to put names on 1,500 Melasodes specimens, and as many people know, that's not easy. And so what we found is that our membership will be able to handle, likely, many thousands of specimens themselves, including entire genera like Hoplitus and Ceratina. Likely Melasodes will be among those, and many others. So once our annual intake of specimens are identified, we voucher representatives in the Oregon State Arthropod collection, and the remaining specimens of common species are distributed in reference collections around the state. The species occurrence records are then published as a data paper through the Oregon State Arthropod collection catalog and served to GBIF. And so you can find our 2018 data on GBIF, and the 2019 data, which includes another 30,000 records, should be released in a few months. Finally, I want to conclude with work being done by curator of the Oregon State Arthropod collection, Dr. Chris Marshall, to complete the Atlas information loop. And this is by developing an interactive online Oregon Bee Atlas. The interactive Bee Atlas synthesizes historical museum records with volunteer records in a geographical map format. The goal of the IBA, or Oregon Bee Atlas, is to provide an intuitive graphical tool to examine the regional bee fauna, and that it provides users the capacity to filter, query, and explore the data. Existing mapping approaches were deemed too slow or user-unfriendly, especially with large data sets, which dramatically increase the rendering time. And so this is working really well so far. I'm really excited about this. Now, we're always looking for collaborators to work with our data. So please take a look at the data we've published so far and reach out to us. As you might imagine, with this volume and quality of records, there's an enormous potential for modeling all sorts of really cool things. And finally, thank you to our funding agencies, the FFAR and USDA NIFA grants, which help get this program off the ground, the ARF grant, which is helping establish our monitoring program, and to Jerry and Judith Paul, Ray Temple and Stephanie Hazen, Missy Martin, and Jean Natter for their generous contributions.